we got a point? Yes, okay. I'm going to tell you a little bit about the extensions on top of the HeLmod system that we built in at Harvard. But honestly, if you get one thing from this talk, it's that there's a whole bunch of reproducible software builds here that are available, and you can use them as you wish. As we've sort of seen here, software publication is easier than it's ever been. There's a ton of different ways in order to make your software available. Journals will publish them, and there's a whole bunch of articles that say, go ahead and publish your software. But however, there's no generally agreed upon standards for any way to do this in particular. And this results in just a ridiculous array of delivery mechanisms. We had some discussion about using Debian and package managers yesterday at the Birds of a Feather, but those, I mean, that's a tiny percentage that's available. There's a ton of this other kind of stuff that you have to deal with if you want to be able to use software and use it reproducibly. And it turns into a huge maintenance burden that basic module systems really don't effectively handle. This is the printout from somebody's module list. It's a partial printout. It goes down to 111. If you look at this in detail, honestly, I have no idea what's actually being run at any given moment in this person's environment. So what HeLmod does is it uses a basic RPM build system and a set of spec files and scripts to construct reproducible, shareable HeLmod deployments. That's really all there is to it. And it's really, really simple set of basic scripts that do most of the work, and it's available from GitHub, of course. HeLmod, in case you're not familiar with it, is a very nice extension to the HeLmod system that forces you to choose compiler and MPI versions before you load anything, and it gets rid of a lot of the interdependency problems there. Different versions of the same module can't be loaded together, and our system is just a few bash scripts and macros on top of that to make it work better. However, the meat of it, really the most valuable part, is the set of spec files that explicitly detail the successful build procedure. And this is an example of what one of these looks like. In this case, it's one of these messes that you come across when you're dealing with these applications. In this case, it's Viz5D+. There's a bunch of sed scripts to fix some bugs in there, and a couple of patches that get thrown in at the same time, just before a regular old configure script gets run. In addition, here's another one. With the HeLmod system, you want to be able to build things from multiple compilers, and that's part of what the code provides for you. And we have a few things like this here, where in the event that you're doing an Intel compiler, you just do a substitution on a GCC for ICC, and everything builds just fine. And then finally, built into these spec files is a set of metadata that gets pulled out, including the build dependencies and runtime dependencies, et cetera, for each one of these applications, so that you can see exactly what those dependencies are, again, in terms of these module files that we load. So in other words, we went through all of this pain. A lot of different other individuals have gone through the similar pain. You don't have to do it. Go find these spec files. Even if you don't use them directly, use the information that's in them, and it'll make everybody's life better. Thanks.